express 1080 as a product of its prime factors in index form? So in order to answer this question easily, all we need to do, we'll have a table for us to express 1080 as a product of its prime factors in index form. We write out our 1080. Then we ask ourselves what's the lowest prime number that can be used to reduce or divide this big number. And the lowest prime number there is 2. So we can use 2 because 2 is an even number and this is also an even number. So we'll say 2 into 10, or 10 divided by 2 is 5. Then 2 goes into 8 4 times, and also we bring down our 0. That means 1080 divided by 2, we have 540. And the next thing to do, we'll ask ourselves what's the number that can be used to divide this without any remainder. I mean the lowest prime number, and the number is still 2. So 2 into 5 is 2 times. We'll have a remainder of 1. The one that is remaining, we'll add it to this 4, becomes 14. All right, so 2 into 14 is 7 times. Then 2 into 0, of course, that is 0. So we'll still use our 2 here because here is an even number. All right, so 2 goes into 270. We have 1 here, and 2 into 7 is 3 times, remainder 1. We add the 1 to this 0, becomes 10, and 2 into 10 is 5 times. Then we have 135. So ask ourselves, what's the lowest number that can go in 135? Of course, we know 2 cannot be used here because we have an odd number, 5 here. All right, so we'll ask ourselves, can we use 3? Yes, we can use 3. So we'll say 3 into 13. We have 4 times because 3 times 4 is 12. We have a remainder of 1. Add the 1 to 5 becomes 15. Then 3 into 15 is 5. Then we also have 45 here. 3 can also be used here. So we'll have our 3 here. 3 into 4 is 1. Remainder 1. Add the 1 to 5 becomes 15. Then 3 in 15 is 5 times. Also, we can still use 3 because 3 times 5 is 15. 3 in 15 is 5 times. That means we can remove 3 from 15 5 times. Then the next thing to do is to bring down 5 here because we cannot use 3 here. 3 into 5, there will be a remainder. So we'll use 5. 5 goes into itself 1. All right, so the next thing we're going to do is to multiply these numbers and show them as index form, or express them in index form. So what do? We write out our 2 times 2 times 2. All right, 2 times 2 times 2 times 3 times 3 times 3. All right, times 3 times 3 times 3, then times 5. And this is now equal to, since we have 2 in 3 places, that means 2 times 2 times 2 can be said to be 2 raised to the power of 3. Why? Because in indices, we are being made to understand that when you multiply the same number by itself, you can bring out one of that number and put it in the power of the number of times it multiplies itself. Excuse me. So if we have 2 times 2 times 2 times 2 in 4 places, 2 multiplies itself 4 times, and we have 2 raised to the power of 4. If it is in 5 times, we have 2 raised to the power of 5. But in this case, we have 3 times. So we have 2 raised to the power of 3. Then we'll bring down multiplication sign. Then 3 raised to the power of 3, because we have 3 times 3 times 3. All right. Then times our 5 raised to the power of 1, because we have only 1 5 here. So therefore our answer is 2 raised to the power of 3 times 3 raised to the power of 3 times 5 raised to the power of 1. Thank you so much, guys, for watching. If you find this helpful, don't forget to follow me on all platforms at Joe King Maths Class, and please do well to share this video. It means a lot to me if you can share this video, and please follow me on Facebook at Joe King, follow me on YouTube at Joe King Maths Class, follow me on TikTok at Joe King Maths Class, and on Instagram at official_Joe King. Thank you, guys. I appreciate your time. Until next time. Bye.